So for Maclaurin or Taylor series, you have to be careful because you have to follow the directions. And there are two basic techniques we learned in class. One was from scratch, in which you use this formula where f of x is, you can put approximately equal or equal depending on what form of the equation you're using. So if I equals 1 to infinity, essentially, then you do f to whatever level of derivative you want, x to the n over n factorial, and if you don't want it to be centered there, so it's Maclaurin over here, or Taylor, if you shift the thing over to A, it's exactly the same formula. There's really nothing profound. It's really identical. Okay, so you can create these Maclaurin series by taking repeated derivatives and then just creating them. Or you can take an existing one, so not from scratch, and going from there. So for example, e to the ix would be kind of a little bit of a pain to do because we already have e to the x, and if we just take every instance of x and replace it with ix, we're good to go. So we already know f of x is 1 plus x squared over 2 plus x cubed over 3 factorial plus x to the 4th over 4 factorial, etc. So e to the ix is going to be, everything's the same. Then what happens to ix when you square it? Well, you get a negative. Oops, the first one's going to be plus, sorry. Then you're going to get minus x squared over 2, but the I is going to disappear. So you know every other term is going to have an I in it. So we're going to have an I over here, ix cubed. But we're also going to have a minus because we had 3 i's. 2 of them turned into a minus sign, and one of them just stayed there as an I. Now we're up to 4 i's, so they all disappear. And then we just keep cycling like so. All right? In the bottom of the question, it says, calculate cosine plus I sine using the Maclaurin series for sine and cosine. And so the I only goes on the outside. So sine, you should know these. And how do we know these? Because cosine starts at 1. So cosine of 0 is 1, so that's pretty easy. Sine of 0 is 0, so there's no 0. So the first thing you see on sine is the x. So if you think about what the sine looks like, it looks like x, close to the origin, right? So the first term is x, right? So then you're going to just keep putting terms in here, except this is going to be alternating. So I meant to say minus. Pluses, minuses. So then we'll have x third over 3 factorial, x to the 4th over 4 factorial, x to the 5th over 5 factorial. Okay? Okay, that should work. Now we want I sine, so we're going to put an I in front of every single thing we have. But it says calculate the Maclaurin series for g of x. It didn't say calculate the Maclaurin series for cosine of x and I sine of x. It said add them. So we add them. And what's so different about adding them versus just writing them is we have to get them in the right order now. Okay, so we've got now the same mess we had above. And you cannot simply say I have the same mess as I had above because the instructions specifically said how to accomplish this. If it had just said calculate the Maclaurin series for this and it didn't say how, then you could have easily just said, oh, well, this is the same as what we got up above, up here. Okay, so this is equal to cosine x plus I sine x. But because the instructions specified how it is to be done, then it's actually stepping you through a proof rather than asking you simply for an answer. There's a difference in intention. So be very careful Make sure if the instructions ask you to do it from scratch, you do it from scratch, and if the instructions say do it using algebra, or implied that you're using algebra, you use algebra. Don't take shortcuts unless you were not. If you were invited to use a shortcut, then you can do it. If you're ever in any doubt, just come and ask.